A student drops a stone from a second floor window 15 meters above the ground. So how long does it take for the stone to reach the ground? And calculate the velocity before it hits the ground. And if another if another stone with twice its weight of the first stone was dropped from the same height, how long does it take to reach the ground in comparison with the first stone? Okay, so air resistance here is negligible. So now we can kind of draw the situation. So the window is 15 meters from the ground, in which that is S lah. So it is downward. The stone is going downward, so negative 15 meter. So the student dropped the stone. He dropped the stone, which means the initial velocity of the stone is 0 meter per second. Okay, and then based on this, we know that this is a free fall situation in which the acceleration is equal to the negative gravitational acceleration lah. Okay, so how long does it take for the stone to reach the ground? We can find this by using SUT plus half AT square. So why am I not using the other two formulas is again because of what information is available. Okay, so just keep in mind you can use all three equations. Where is it? All three equations, but if the information is not enough, you have to stick to one equation that is suitable lah. Okay, all right, so now let's continue. So SUT negative half GT square. I just convert the A to negative G. Okay, right, so from here we just substitute negative 15, U is 0, half 9.81 T square. So from here we get the time to be equal to 1.75 seconds. Now we have to calculate the velocity before it hits the ground. Okay, so the velocity before it hits the ground, we can use this formula, negative 2gs. Again, I directly convert the acceleration into negative g. So from here, just substitute the values, negative 2, 9.81, negative 15. Okay, so we will then get the velocity to be 17.2 sini masih square belum meter per second. So you get the velocity before it hits the ground to be 17.2 meter per second. Okay, you can actually also use the time equal to 1.75 seconds, but I feel like it's easier for you to just directly use this just in case you get the time wrong in the first questions here lah. Okay, alright, so now theory questions. If another stone twice its weight, so the other 2 times of the weight of the first stone. Okay, so they've cakap the first stone is dropped from the same height, and then how long does it take? Okay, so will the time be different just because the weight is different? Well, actually the answer is it would be the same. It will still be 1.75 seconds. Okay, so why is it like that? So actually for free fall, the downward net force, okay, the downward net force is only weight. Okay, it is only weight. So the ratio of their weights to the masses are equal. Okay, so the acceleration, acceleration is independent. Okay, it is independent of an object's mass. Okay, right? So acceleration is independent of the object's mass. So no matter how heavy one of the stone is, they will always fall. They will always reach the ground at the same time. Okay. All right. So that is question 5.